Hi, in this video we're going to introduce our section on complex fractions, and we're going to look at how to simplify them in this group of videos as well. So what is a complex fraction? Well, it's a rational expression, so it's a fraction, which contains other rational expressions in the numerator and or denominator. So they're fractions within other fractions. So here are some examples of some complex fractions. So we have 2 minus x, or 2 over x minus 3 in the numerator, and then in the denominator we have 5 over x plus 7 over x. Over here in this next one, even more crazy looking, we have in our numerator x over x plus 1 plus 7 over x, and then in our denominator 3 over 2x plus 8 over x minus 4. So we have these little tiny fractions within the bigger fraction. And simplifying complex fractions involves working with the expression until there is, at most, only one fraction bar in the entire expression. So here in this first one, we have a total of 1, 2, 3, 4 fraction bars. We have 3 tiny fraction bars and 1 large fraction bar. And in this one, we have 1, 2, 3, 4 small ones and 1 large one. So we have 5 fraction bars in this one. That's what we mean by complex fractions. Too many fraction bars. We want at most only one. So recall that when we add or subtract fractions with unlike denominators, we need to find a common denominator first. Now, rather than take this approach with this section, which we absolutely could, by the way, we could simplify and then divide by a fraction means multiply by the reciprocal. There's nothing wrong with that. We're going to clear out our tiny fractions by multiplying every single term, but what I like to call the least common tiny denominator, or LCTD. So what is it? Well, it's the least common denominator of all the tiny fractions in the expression. So the nice thing is when you multiply every single term by the least common tiny denominator, even terms that aren't fractions, it's guaranteed to get rid of all the tiny fractions. Guaranteed. So to find the least common tiny denominator of numbers, such as coefficients, find the least common multiple of those numbers. So for instance, with 3 and 5, it would be 15. With 4 and 6, it would be 12. And then to find the least common tiny denominator for variables, select the highest power of each variable. So if we have an x and an x squared, you'd want the x squared. So take the larger power. All right, example 1, we're going to simplify each of the following as much as possible. We have part A, we have 3 plus 1 over x all over 2 over x plus 4. So I just use parentheses to group them together. So looking at our tiny fractions, we have a 1 over x and a 2 over x. So those are nice because they have the same denominator, which makes x our least common tiny denominator. And so what we're going to do is we're going to multiply every single term, all 4 of them, by x. So we're going to take 3 times x, 1 over x times x, 2 over x times x, and 4 times x. When we do that, we get 3 times x is 3x, plus 1 over x times x is just 1. The x's cancel out. So notice in this big denominator, there's no more tiny fractions. Now in the in this big numerator rather, there's no more tiny fractions. Now in this big denominator, we're going to multiply each of those terms by an x as well. So 2 over x times x, the x's cancel out, leaving us with just 2, and 4 times x is 4x. So notice in our answer here, there's only one fraction bar, and there's no more tiny fractions. So we've simplified this actually as much as we possibly can. All right, part B, we have 1 minus 5 over x squared, and then in our big denominator, we have 2 over x squared minus 7. So much like the last problem, we have an x squared and an x squared. Our least common tiny denominator is x squared. So if we multiply every single term, all 4 terms, by x squared, guaranteed to get rid of all tiny fractions. So let's do that. We got 1 times x squared is going to give us x squared, minus 5 over x squared times x squared. The x squared and the denominator, tiny denominator, cancels out, and we're just left with a 5. So our big numerator is just x squared minus 5. Now for the big denominator, 2 over x squared times x squared is just 2. And then minus 7 times x squared is negative 7x squared. So our final answer is x squared minus 5 over 2 minus 7x squared. Again, notice only one fraction bar at most in this answer. All right, that about does it for this video. Thanks for watching. I'll see you next time.